So let's have a look at 2019 question 4A in applied maths. We're given this very straightforward pulley system whereby we have two particles of masses 0.4 kilograms, there's that 0.4 kilogram mass, and 0.3 kilograms, and they're attached to the ends of a light inextensible string. That means we have tension, and both of them pass over a smooth light fixed pulley. There's my pulley up here, and it's a pulley that's not moving. So the two masses are held at the same level, as we can see in the diagram. The system is released from rest, and we're asked to find two things. We're asked to find the tension in the string, and we're asked to find the speed of the 0.4 kilogram mass, this mass here, when it has descended 0.7 meters. Straight away we'll go ahead and put in a force diagram. We'll start off with our weights. The 0.4 kilogram mass will have a weight of 0.4 g, W is equal to mg, so there it is there. And the 0.3 kilogram mass will have a weight of 0.3 g. There's only one string, so there's only one tension, so we let it be represented by the letter T. Tension acts along the string away from the object, so there's the tension force on the 0.4 kilogram mass, and there's the tension force on the other 0.3 kilogram mass, so we're letting that represented by T. Let's just declare now the directions of the accelerations so we can apply Newton's second law properly. Clearly the 0.4 kilogram mass is going to go down with an acceleration A, whilst the 0.3 kilogram mass will go up with an acceleration A. Both accelerations are the same because there's only one string. Okay, so here we go, F is equal to ma. Let's bear in mind, of course, that g, the acceleration due to gravity, is 9.8 meters per second squared. So here we go, we're going to apply F is equal to ma to both these particles. Let's apply it to the 0.4 kilogram mass first. 0.4 kilogram mass. So what forces are acting in the direction of the acceleration? Well, it's going downwards, so we're going to start off with 0.4 g minus t is equal to the mass, which is 0.4 times the acceleration, which is a. We can rearrange this equation to have the unknowns on the left hand side, so that will give us t plus 0.4a is equal to 0.4 g, and we will call that equation 1, okay, and we'll come back to that because we're going to need that later on, okay, equation 1. Okay, superb. So then we're going to work on the 0.3 kilogram mass. That's the other mass, and apply Newton's second law to that. Well, that's going upwards, so it's t, all the forces in the direction of the acceleration, c, minus 0.3 g is equal to the mass. Well, what's the mass? 0.3 times the acceleration, which is a. And again, we'll rearrange this equation. We'll rearrange this equation to have the unknowns on the left hand side. We'll have t minus 0.3a is equal to 0.3 g. So very good, so we'll call that equation 2. So we're looking for the tension. So if we're looking for the tension, what are we going to do? We're going to actually eliminate the accelerations. And we can do that by taking equation 1 and multiplying by 0.3, and taking equation 2 and multiplying by 0.4. So when we do that, equation 1 will turn into 0.3t plus 0.4a by 0.3, that's 0.12a, is equal to 0.4g by 0.3, which is 0.12g. Okay, and the second equation we're going to multiply by 0.4, so it's 0.4t minus 0.12a, and that's equal to 0.12g. Okay, so let's add these two equations together. When we do that, the a's will cancel. We'll end up with 0.7t is equal to 0.24g. We'll now actually replace g. T will be equal to 0.24g divided by 0.7. Well, 0.24g, 0.24 by 9.8 is actually equal to 2.352 divided by 0.7. When we do that, we'll get our t value, and our tension value will be divided out by 0.7. I have a calculator next to me here. My tension value is equal to 3.36 newtons. So superb, we've worked that out, and that didn't appear to be too difficult. So t is equal to 3.36 newtons. So we can use the t. We're going to need this t value to work out the speed in the second value. So t is equal to 3.36 newtons. So let's go on to the second part. And this is a UVAST problem, really. So it's UV AST from your linear motion. And what we have here is we're going to fill in the values, use my initial velocity. What's my initial velocity of the 0.4 kilogram mass? Well, it was at rest, so the initial velocity is 0. Its final velocity is what I'm actually looking for. It's the speed after a certain point, or final velocity after a certain point. So I'm looking for v. The acceleration I can find, I can find my acceleration from equation 1 there, or indeed equation 2, but I'll use equation 1. S is 0.7, there it is there, so S is 0.7, and I'm not really interested in C, but that's okay, because I'm going to use v squared as u squared plus 2as, that equation, and that equation has no t in it. I'm going to, we're going to solve for v using that problem, okay? So using that equation. So here we go, let's find a first. So if we actually rearrange the first equation, a will be equal to 0.4 g minus t all divided by 0.4. Okay, now when you work that out, let's have a is equal to 0.4 by g. Well, g is 9.8 minus t. What's the t value? Well, we worked it out earlier on, is 3.36, all divided by 0.4. And my a value is 0.4 by 9.8. 0.4 by 9.8 is 3.92. So it's 3.92 minus 3.36, all divided by 0.4. So a will work out to be 3.92 minus 3.36. 3.92 minus 3.36 is 0.56. Divided by 0.4. When we work that out, we get a as being equal to 1.4 meters per second squared. Okay, so that's the acceleration of each particle. That is not my final velocity. I'm going to use that a and put it in here, 1.4. So I clearly have everything I need to work out my v, which is what I'm looking for. V squared is equal to u squared plus 2as. Well, that's going to be just equal to 2as because u is 0 and the starting speed is 0. So it's going to be equal to 2 times a is 1.4 by s. Well, what was the s value? 0.7. So when we work that out, we get that equal to v squared will be equal to 1.96. Taking the square root there, we get v is equal to 1.4 meters per second, and that's my answer to part 2. And that concludes a pretty straightforward A part in 2019.